Alright, so we are on to Chapter 1, Lesson 7. We're learning how to compute the numbers written in scientific notation. So we're going to learn how to multiply, divide, add, and subtract. So first we're starting with multiplying and dividing. For example 1, we are evaluating 7.2 times 10 to the third and times 1.6 times 10 to the fourth. So our first step here is we are going to group our similar factors. Because of the commutative property and associative property of multiplication, it does not matter what order you multiply these four factors by. So what we're going to do is take 7.2 times 1.6, and then we're going to multiply that by 10 to the third and 10 to the fourth. So we're grouping our tens and our whole numbers. Once we get here, all we're doing is multiplying. 7.2 times 1.6 gives us 11.52. And then when we take 10 to the third times 10 to the fourth, what do we do with those exponents? We add them. So we are adding 3 plus 4. So we get 11.52 times 10 to the 7th power. For examples A and B, you guys work on that. Remember to group these similar factors, because our end result is always to have a times 10 to some power. So we want to make sure to group our tens together and our whole numbers together. Okay, in 2010, the world population was about 6,860,000,000,000. The population of the United States was 3 times 10 to the 8th. About how many times larger is the world population than the United States? So we're taking the world population to the United States population. Okay, so first our book tells us to estimate the population of the world. So we know that's 7 billion. And if we write that in scientific notation, that is 7 times 10 to the 9th. So our problem is asking us, how many times larger is the world to the population of the United States? So this is actually a division problem. We are going to take our world population, and then we're going to divide that by our United States population. And from here, it's a lot like our previous example. We are going to group 7 divided by 3. So we'll do 7 divided by 3, and we'll get 2.3. And then we're going to group 10 ninths divided by 10 eighths. And when we divide our exponents, what do we do with those exponents? We subtract. So we're going to take our base of 10, do 9 minus 8, and that gives us 10 to the first power. So for C, you are going to you're going to pay attention to the largest Great Lake, which is 8 times 10 to the fourth square kilometers. And then you're going to look at the surface area of the smallest Great Lake, Ontario, which is 18,160. About how many times as great is the area covered by the Lake Superior than Lake Ontario? So this says Lake Superior to Lake Ontario. So Lake Superior is going to be divided by Lake Ontario. So what you need to do is take 8 times 10 to the fourth and divide it by Lake Ontario's scientific notation. Now we are adding and subtracting scientific notation. So our book tells us when adding or subtracting decimals in standard form, it is necessary to line up the place values. In scientific notation, the place value is represented by the exponent. Before adding or subtracting, both numbers must be expressed in the same form. So that tells us that in scientific notation, when we add and subtract, our exponents must be the same. So if we go down to example 3, you can look at this and see that for our first number, we have 6.89 times 10 to the 4th power. For the second number, we have 9.24 times 10 to the 5th power. Somehow we need to get these to have the same exponent. So what we're going to do is we're going to take our second number and change it to the 4th power. So we want times 10 to the 4th power. How are we going to do this? So when we move 5 down to 4, what we have to do is take this decimal and move it to the right once. So now we have 92.4 times 10 to the 4th power. You can always check this. If you take either of these representations and move your decimal according to your exponent, they'll be the same number. But now back to our example. We are going to add 6.89 times 10 to the 4th to 92.4 times 10 to the 4th. Okay, and here we know we can add because we have them both to the 4th power. Our next step is simple. We're going to take our numbers in the front, add them together. We'll get 99.29. And then we'll keep our ending the same. We have 99.29 times 10 to the 4th. Our very last step is we need the correct scientific notation. So I do this in 2 steps. I'm going to write out our answer in standard form. So I'm going to move this decimal right 1, 2, 3, 4 times. So that means it's becoming 1, 2, 3, 4. 992,900. So from here, I'm going to rewrite it in scientific notation. Start my decimal at the end. I know 1, 2, 3, 4, 5 times. Now we have 9.929 times 10 to the 5th. And that is our final answer. So our steps here are to match our exponents. Okay, that's when we move our decimal according to our changing exponent. Our second step is just to add our front numbers, which are also called coefficients. And then our third step is to correct the scientific notation. So for number 4, to combine these, we have to have our second number written in scientific notation. So we're going to start that, which we know how to do, a decimal at the end. We moved it 1, 2, 3, 4, 5, 6, 7 times. So now we have 1.161 times 10 to the 7th power. So that is our new number. Okay, now we check our exponents. 1's to the 8th, 1's to the 7th, we know we need to change it. I'm going to change our first number. If we change this to a 7, what we have to do is move this decimal to the right. So now we have 78.3 minus 1.161 times 10 to the 7th. Sorry for the interruption. Back to this. Our exponents now match. So all we're going to do is add our beginning numbers together. Well, subtract our beginning numbers, and we'll get 77.139 times 10 to the 7th. So far, we've matched our exponents, we've subtracted our beginning numbers. Now we have our last step. We have to correct this scientific notation. So to make this 77.139 a number between 1 and 10, we're going to move it to the left once and turn the 7 into an 8. So now we have 7.7139 times 10 to the 8th power. For example 5, we're going to turn 593,000 into scientific notation. So take this 1, 2, 3, 4, 5 times. We get 5.93 times 10 to the 5th power plus 7.89 times 10 to the 6th power. Our last step is to match these exponents. So if we are going to match these exponents, I'm going to choose to change exponent 5 to take the exponent 5 and turn it into a 6. So I'm going to just move it to the left one time. And now we have 0.593 times 10 to the 6th power plus 7.89 times 10 to the 6th power. After that, we just add our beginning numbers. We get 8.483 times 10 to the 6th. And from here, we know that this scientific notation is correct, so we are finished. So while you guys are trying D and F, remember, your first step is going to match your exponents. And then you're going to add your front numbers and correct the scientific notation.